But there's another school of thought, right? People like Nuno Gill, who's pictured here, who's a professor at the Manchester School of Business. Nuno was here actually about a year and a half ago. He even taught a Gyan course, but I think you guys were probably very early on, and I don't think any of you took that class. So he has a slightly different view, right? He says, look, people analyze the information that they have, right? So initially at the start of the project, right, it's essentially only the project promoter, right, who sort of says, I want to build this airport, or I want to build this railway, or whatever. They don't necessarily get down to doing a detailed design. For instance, detailed design is done later, right? When you've decided, you give it to an architect, a designer, and they actually figure out how much reinforcement is designed, etc. So at this stage, people tend to have more ballpark sort of figures. So they start going with, okay, per square foot, this is generally what this kind of a project costs. So if I'm developing an airport, then I look at a few other airports and I sort of say, okay, per square feet, this is roughly the cost. My airport is sort of so big, and therefore this is roughly the cost that is going to that I'm going to have to sort of figure in my outlay. But then what happens is, as the project progresses, more and more stakeholders with information start entering. Right? So you actually have people who are doing the land acquisition, right, who probably have a better idea on what the land is actually going to cost. You actually have architects who come in and say, okay, this is the kind of architecture, and therefore the quantity of materials that you might have had in mind, probably a little bit less than what you want to have if you want to have an iconic building. You have mechanical, electrical engineers who are coming in and sort of saying, for the kind of airport that you're building, the air conditioning that you have to do, the baggage handling systems that you have to have, the energy requirements, etc., are probably going to be this. So as more and more people come in, you get more and more precise information about what that airport is going to need and how much it is going to cost, right? And so essentially what Nuno says is, at the beginning, because you didn't have enough information, right, you came out with a ballpark estimate, right? And as you get more and more information, you discover things that perhaps you did not anticipate earlier, right? And those then tend to shoot up the costs, right? So one of the examples that he gives, and I think this is there in one of the papers, I'm not sure, is he's done a lot of analysis on a bunch of mega projects in the US. I think this was the London Olympics, if I remember correctly. Okay, so let's just follow the blue line, right? So the blue line is the cost forecast line. Okay. The London Olympics were in 2012, but London bid and won the Olympics, the right to host the Olympics, much earlier, right? So I think it was the late 90s or whatever, when along with other cities they competed, they set up, they won the bid, right? At the time when you win the bid, right, so one is you have to convince the International Olympic Committee that you are worthy of hosting the games, right, that A, you will be able to host it seamlessly, and B, that it will add some value. I mean, you will bring in some unique touch that Madrid and Tokyo and whoever you were competing against would not be able to bring, right? So so that's one part, right? But internally, right, you also have to convince your treasury, right, or your finance department or whatever, because this is a country doing it, it's the government essentially doing it, that you have the money to do this. Right? So you got to do both. There's no point just showing a wonderful presentation to the International Olympic Committee and then you come back and you find that your country is not able to support it. So you've got to do both. So when they started off, okay, this is roughly what they thought it would cost. Okay, so roughly they thought that this would cost about £1 billion, right? So it's 1,000. This is the scale is in millions, right? So they thought it would cost £1 billion. Okay, but as things progressed, right, look at what happens to the blue line. Right, the blue line keeps going up, right, until finally when the Olympics were finished, and there's always a little bit of post work, which is why the timeline doesn't stop at 2012, although the Olympics finished at 2012, there's still sort of a little bit of cleanup, etc. You end at $8 billion, right, which means your overrun is how much? It's like 800%, right, it's 8 times. Okay, so then he asked the question of why did these guys go from, I mean, I know you can't estimate precisely. If 1 billion went up to 1.2 billion, so fine, these kinds of things happen, but how can 1 billion go up to 8 billion? I mean, these numbers have like no relationship, right? I mean, treasury approval for 1 billion, I can amend that approval for 1.2 billion. How do I approve 1 billion and end up spending 8 billion, right? And essentially he talks about how throughout the process, more and more stakeholders started coming in, and the cost of this thing. So one sort of example is, when you think about the cost of the Olympics, what do you think about? Right? If I asked you, okay, Chennai wants to host the Olympics at some point, what is it going to cost? What are the elements that you will try to cost? Stadium construction, right? Okay, great. What else? Accommodation, games village, etc. What else? Right? Transportation. Right. Now, for instance, so what we are starting to get at is the things outside the games that you need to sort of cost, right? So you've got, okay, transportation. Let's sort of, okay, what else? Marketing expenses. Okay, very good. Okay, what else? Land for building the stadium. So building the stadium, let's say all of that comes in. Okay, all the electricity, you know, to run everything. Okay, so it's not just the civil works, it's all where the energy going to come from, etc. Huh? Pollution control measures. Okay, that's something to think about. What else? All right, so these are all great, okay, but I think so what you'll also realize if you think through this, and if you think through it long enough, I'm sure we'll get into this. You've got to realize that when you build all these stadium, etc., right, it's not just a few thousand athletes who are going to come in, right? You're going to get a few million or few, you know, tens of millions of people coming in to watch the games, okay. Now, then that raises questions of where are they going to stay? Right. I mean, I can build a games village for, you know, a few athletes. I mean, India sends, I don't know, a few hundred people. The US probably sends about 500 people. I don't know what the numbers are, but these are manageable numbers, right? But what happens if a million people descend upon my city, right? Where are they going to stay, right? Some infrastructure needs to be built. How are they going to get in from venue to venue? This is not saying, you know, festival time is coming, there'll be 10% extra increase on the traffic. Right? You might see considerable amount of stress on your existing infrastructure system, whether it's autos or Ubers or buses or metro rails or whatever, which means you actually have to start investing a considerable amount of money in upgrading, say, your metro. So in the UK, the entire what they call the tube, right, which is the underground train infrastructure, needed to be upgraded, right, for the Olympics, right. So it wasn't just let me lay a few roads, it was essentially saying I've got to completely upgrade my underground tunneling infrastructure because I'm going to have more people come in, I might have to run trains at higher frequencies, etc. So these are things that you may not intuitively think about when you think about Olympic Games. You might think about stadium and you might think about sports village and all of these other things. But what happens is as more and more, okay, so experienced people will think about some of these, but what exactly will be the cost of upgrading the tunneling and train infrastructure system? Very difficult for the Olympic Authority to get a number. Yeah, I can talk to a few people, I can get a ballpark, but only when I start getting into details of how many do I need to build new stations, do I need to expand, do I need to buy new trains to run it at a particular frequency, will I actually come at the number. So these are the kinds of things that keep happening, right, which raises these costs, okay. And essentially what happens is the cost keeps going up, and the reason you find relatively flat portions here is at some point the Treasury in the UK said, look, you guys are irritating, right? You're just constantly coming up and asking for more money. You said 1, then you came up to sort of 1.5, 2, 2.53. I mean, this is sort of never ending, right? So you know what I'm going to do? Somewhere here, I'm just going to raise this, right? Whether you guys, you might actually have projected something like this. Okay, but I can't just sort of have a meeting with you guys every month or every 2 months and just keep raising it by, you know, a few $100 million. You know what, I'm going to raise it by, I don't know what this is, right, 2 billion, all right, and therefore you use it for the future, and therefore these guys came up. So that's why you find a little bit of a dip here, because it's not as if they didn't have a cost overrun here. It's just that this increase was way steeper than what they had asked for, and so it actually covered this entire period, and it still kept going up, as you can see. Then it sort of flattens out there a little bit, right? So Nuno's version is, it's not optimism bias, right? It's not that I'm overly optimistic. Optimistic means I have data, but I choose to pick the the optimistic source, right? I'm not purposefully deceptive, right? I just don't have the data, right? In both optimism bias and purposeful deception, I assume you have the data, but you choose to believe one end of the standard, the distribution curve, or you choose to purposefully look at a certain number. Here I'm saying, look, I don't even have that distribution. I don't know, right? Because more and more people are sort of coming in as the project progresses, and that's sort of essentially the story of these mega projects. And you will find that in many mega projects. For instance, even if you take our own Chennai Metro Rail, right? I remember an article in the newspaper when phase 1 was starting. Metro Rail had initially decided to start from point A and end at point B, and the people who were a bit downstream from point B suddenly started lobbying and saying, why are you coming all the way to point B? Can't you like go to point B plus delta, right? Because that would cover us as well. And because of the politically sensitive nature of that area, etc., I think a decision was made to go until B plus delta, right. So, but again, when the initial proclamations were made, when the initial time estimates and cost estimates were put out, you were only looking at start to point B, point A to point B, right. Later on, you actually have new stakeholders coming in, right, putting more demands on the project, and in this case, therefore, the length and the time and the cost and all of that sort of increasing. Now, technically, these come under cost overruns, all right, although there was a little bit of a change in scope, etc. So, these are classic cases of people saying, yeah, you started at a point where you didn't have complete information. And over a period of time, you get more and more information, right, the project balloons out, yeah. So, the Olympics is very difficult to sort of say because different Olympics are different. Right, the number of people landing up in the UK would have been fundamentally different than the number of people landing up in Brazil. What it would take for Brazil to gear itself for the Olympics or Rio, right, is a little bit different from London because where they're starting with regards to infrastructure is fundamentally different. So, Greece, for instance, Athens hosted the Olympics at some point. Their starting point in some ways is much lower than a city like Atlanta, right, which, by the way, had Georgia Tech University, for instance, hosted a number of the games, and there was no real need to build stadiums because that university had world-class facilities. So, it's very difficult for me to learn from Olympics because they're all so geographically dispersed, number one, and they all happen once in 4 years. So, you get one Olympics once in 4 years. Your data points are very minimal, right, and again you have that tendency to be able to say, oh, I know this happened, and we saw the Montreal case, right, we read about the Montreal Olympics case, not very dissimilar, right, things skyrocketed for a number of reasons, okay, which are similar to this, but again you sort of go back and say poor planning, okay, so it's a little bit possibly of a mix of being a bit optimistic, but also not having enough information at the start, okay, so this is this guy's explanation, right, perhaps in reality, again, this also makes some amount of sense. So, perhaps in reality, we have to blend both. So, this is sort of, Nuno Gill's idea is he says, when you look at the project organization, right, the number of organizations that are involved in looking at the project, this is what happens over time, right. Right in the beginning, you have a small core group of people, okay. That core group starts becoming bigger and bigger, right. And when we talk about a core group, we could talk about people who have a decision-making role in the project. So, we're talking about a consultant who can actually come and make a design change, right, who has the authority and the power to make a design change. So, that those kinds of people are part of the core group. So, the core group keeps evolving, and at a certain point of time, you have perhaps what he calls the periphery that starts to form, which are a number of people who you depend on for information, but may not necessarily be able to change the project. Right, so some supplier might say this particular material you're using is in short supply, I'll supply it for you, but you might have to pay a little bit more. So, these are people on the periphery of the project, but your core network keeps increasing, right, and as the core network increases, more issues come up with regards to the project, right. So, essentially the point is promoters are part of the central core that makes decisions with actors on the periphery, and the promoters are the one who control the sequence with which people come in. So, for instance, there is no harm in the Olympic Development Authority or the British Olympic Authority or whatever they call themselves, bringing all these people together, doing a detailed cost estimate, right, and actually working out how much the rail infrastructure needs to be strengthened, etc., how much this stadium needs to be refurbished, what new stadium needs to be built, who the architect is, what that design is. There's nothing stopping them from doing all of that work before going and presenting in front of the International Olympic Committee to host the project, to host the Olympics. The reason you didn't do that in this case is if you did all of that work and you were not awarded the Olympics, it's a waste of time. Right? So, there is nothing stopping us from getting all the information up in the beginning, but it is a very time consuming process, right, before you can actually start the project, and because of a variety of reasons, because you want to start the project, you start with a certain amount of information and then keep adding more people onto the network, right. So, the promoters then control who comes in, number one, and when do they come in, right. So, when do we really bring in the NGOs who have social and environmental concerns in is a decision that promoters need to take. You can have that meeting right at the beginning of the project, you can have that meeting even before you start the project, right, or you can have that meeting 1 year after the project, right. It's up to you as a project developer to decide when to bring them in. Bringing them in early is good, right, perhaps they can work with you as partners. Bringing them in early might also lead to a delay in when you can actually count the start of the project, right? And so you have to strategize that decision, right? But the fact of the matter is that if you ignore the right people at the right time, it could be costly, right? So it's sort of the Goldilocks kind of effect, no? You don't want to bring in people too early, right? Because then they are sort of causing confusion. You don't want to bring in people too late because then they are suggesting changes that are costly. How do you bring in people at the right time? So this is one of the big challenges, right? So, and this is sort of what he calls polycentric governance. He says it's not that one person is making all the decisions, right? Because no one person can understand how to build a metro rail network or how to build an Olympic stadium or an airport or any of these mega projects. The expertise is vested in different people. Only the baggage handling guys really understand the baggage handling technology and how they can implement a baggage handling system in the kind of airport design and layout that you are giving them, right? Baggage handling is a relatively complex thing. As soon as your bags come off the airplane, right, many things happen. Some of them need to go to the carousel for people to pick them up, but some people are in transit, right, which means the bags automatically need to go to wherever they are transiting to. And you know, people getting off a flight, 50% of them are maybe going out into the city, 50% are going elsewhere, but each of them are going somewhere else, right? Someone's landing in Chennai and going to Nagpur, someone else is going to Indore, someone else is going to Mumbai. So sorting all of this out is not trivial, right? So your baggage tags, you know, are critical. They need to be read, they need to be sorted. Sometimes your connection, right, is only half an hour. So you get off the flight and you board the next flight, but somehow your bags need to get off and make it to the right flight in time as well, right? So these are complex issues. So how much does it cost to put in a baggage handling system and how does it work? I don't know, right? L&T wouldn't know, right, because they know the civil engineering part of it. BAE or, you know, one of these large international baggage handling systems, the guys would know. So when do I bring them in, right, is the question. If I bring them in too early, I risk compromising my architectural design for the baggage handling, right, for what would be easier for baggage handling. If I bring them in too late, right, not sure how that would work either, right. So therefore, so the point is the whole governance cannot be done by one person. Right, that's polycentric in the sense it means there are many centers, right? There are many people who have decisions that they make to govern these kinds of projects, okay? So how do you manage this? How do you make projects finish on time and on budget? One is think through how you would sequence when you would bring people in, right? We've seen cases where NGOs are brought in very late in the process, create a huge ruckus, right? And that really adds on extra cost to these projects, right? So you've seen those costs, right? Another option is you just build in cost and time buffers, right? You sort of do the opposite of purposeful deception. You purposefully put in buffers, right? You say, okay, you know, I think, you know, it's going to take 12 months, so I'm going to say 18, right? I think it's going to take this much. And so that is a very difficult decision to make, right? It's very difficult to go to a finance department and say, can you budget 10,000 crores for this project? I think it will only take 8,000, but I want you to budget 10,000. That becomes difficult because these guys are saying money is scarce, right? If you don't need the 2,000, I will invest it in healthcare, I will invest it in education. There's so many other places I can put it in. Why should I earmark it for you? So very difficult decision, but given the history of mega projects, maybe it's necessary, right, to put in those buffers, right? Can I design it in such a way that, you know, even if a stakeholder comes in later, right, they don't really have to change the design very much. So this was the football stadium, football example, right, that was being presented. We know that the Olympic stadium, the main track stadium, is only going to be used for 1 week, right, because even though the Olympics are 15 days, the track events are only for 1 day. After that, do you need a dedicated track stadium, right? There aren't that many track events that happen that you need a dedicated track stadium. On the other hand, as many of you will be familiar, the UK is, football is very, very popular in the UK, possibly the most popular sport in the UK. And you could convince, you know, a London-based team such as Arsenal or somebody to take over the stadium, right? Because everyone's looking at, you know, worldwide viewership is increasing, people want bigger stadiums, fancier stadiums. So some of these football clubs are looking for different stadiums. So it would be great if you built the stadium, but if the stadium was then very quickly bought over by, say, Arsenal, right, or whatever, some other, you know, London-based sort of club. Now, and sort of that also saves you a lot of money, right? But the point is, an athletic stadium and a football stadium are a bit different, right? So in an athletic stadium, for instance, there is a 100-meter set of track, which is where a lot of people are really going to watch, okay? You don't so much care about, you know, people, so that's sort of the prime seating. But when you watch a football match, you want to be able to get a good view irrespective of where you sit, which means the way you design pillars and columns, etc., are a bit different. So the question is, and going back with what we talked about yesterday in terms of flexible design, can we actually, think through and build in design, so whether it's arsenal or whether I give it out for some other purpose, right? So for instance, in the US, in American football, there's a team in San Francisco called the San Francisco 49ers, right? So they play American football. Right now they're doing terribly. I think they've won 1 out of 7 matches they've played this season or whatever. But they just built a brand new stadium, right? Sponsored by Levi's, the jeans company. It's called the Levi's Stadium. In fact, they should no longer be called the San Francisco 49ers. They should be the Santa Clara 49ers, because the stadium is no longer in San Francisco. It's in Santa Clara. They play 8 games a year, okay? Because the football season is 16 games, 8 home, 8 away. Each game is whatever, right? A couple of hours, okay? So you're building an entire stadium for like 16 hours of action over a year or 25 hours of action over a year. How much sense does that make, right? Which means you've got to think about what you're going to do with that stadium in the meantime. So what do? Rock concerts happen at that stadium, right? The CEO of Cisco, right, this large telecommunications company in the Bay Area, this guy called John Chambers, just stepped down a year or 2 ago. His farewell was done in that stadium. Right? So you have to therefore think of making the stadium multi-purpose, so that as other stakeholders come in this case it was a club trying to come in and buy or sort of use part of that stadium. You design it in such a way that the stadium can be used later, or that facility can be used later, or whoever the stakeholder is that comes in, finds a way to work with that sort of piece of infrastructure. So can you future-proof designs? Could be costly, right? Because you don't know whether that person will come in or not, but maybe that's something that you do. And also you've got to sort of figure out, where do you draw the line, right? Where do I actually build something extra versus where do I not? And there you probably need some sort of umpires or referees who can actually resolve that. So essentially what Nuno Gill says is, it's not about optimism bias, it's about the fact that you don't have data. Right? If you don't have data, this is what you need to do. Right? You need to bring people with data in as early as possible at the right time. You need to build in cost and time buffers because you don't have the data. You've got to sort of try to build designs which don't need to be changed later on because you've taken care of contingencies in the future. And you've got to sort of bring in some kind of dispute resolution mechanism so that scope just does not keep getting added on. Okay. Of course, there are risks, and they were presented. You get actors in too early, you get important actors in too late. Right, all of these kinds of things, okay, and you might still get uncertainties that affect the project that all your buffers, etc., could never really meet. Okay, so an example: Chennai Metro Rail Phase 1, original cost was budgeted at 14,000 crores. Okay, this is for Phase 1. Phase 1 came in at roughly about 19,000 crores. Right, number of reasons, including reasons relating to foreign exchange fluctuations and so on. Right, because some of the borrowing was from the Japanese, etc. Right, but when you look at some of the reasons, you will find that the land acquisition costs were higher than, give me a second, the land acquisition costs were a bit higher than planned. Okay. So again, you budgeted something for land acquisition, but then when you started negotiating with people and you found out the actual guideline values were different from the market values, and tried to resolve all of this, there was sort of an increase in costs, right, which you probably didn't budget for. Again, was it optimism? Was it strategic misrepresentation, planned purpose of deception, or is just the fact that you didn't have enough data? Okay, there were several scope changes, right? And I think I might have spoken about one of these earlier, which I find very interesting. There were several, but one of the interesting ones was, if you guys see the metro rail going to the airport, okay, you will see that close to the airport. Have I told you guys this before? Okay, so observe next time you go to the airport. You'll see that the metro rail is going above ground, right? You'll see that it suddenly dips underground very close to the airport, but comes back up above ground, right? So when you get out at the airport, right, you're still above ground at the same elevation, right? So you should be asking the question, what's happening? I mean, you're going overhead, right? Why don't you just continue to go overhead, right? Why are you sort of going loop the loop? Okay, and so I call it the world's cheapest roller coaster, right? So for 50 rupees you can go up and down. It's literally 500 meters, right? And the reason that happened was, for a variety of reasons, Metro Rail decided we'll build this above ground. It's cheaper, right? And we have that large road. We can put piers on that road. We can build it above ground. All of that was fine. But as they were constructing, so after all of this was approved, after the funding was obtained, after the designs were done, right? After the construction started, the Airports Authority of India said, hey, we have a problem. right? We have, you know, an emergency runway, rarely used or whatever, but that is perpendicular to the main runways. And it turns out that if an emergency landing has to happen on that runway, something like this, then if a metro rail is actually passing at more or less the eye level of the pilot as he's landing, then that might cause a distraction, right? And therefore, near that runway, we cannot have the metro rail going. So essentially, they said, look, we cannot have the metro rail. Right? And so there was sort of major argument, there was this debate on what is the safe distance that will not tend to distract a pilot, and you know, some experts said, oh, the metro rail is already being built at that safe distance, and others said, no, 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 you are not at that safe distance. Depends on the assumptions that were being used for that calculation. So finally, the metro rail said, look, this is delaying the project too much, right? So I will bear some extra cost and I will go underground, right? So now remember, this now costs as a cost, this now counts as a cost overrun. Right, this is part of that 19,000 crore, right? But again, it's possibly because a key stakeholder was involved a bit later in the process. Had the Airports Authority been involved much earlier and you had found this out earlier, then worst case you could have at least just budgeted in, or you could have said that critical stretch, because there's also the Officers Training Academy, which is also somewhat sensitive, etc. Let's just go underground in that stretch, you budget it, right? So you see that these kinds of explanations are starting to come through, even when you look at these kinds of projects, okay? All right, so that's part one. The second is the whole uncertainty by design. Let's see how much we have.
So I'll be presenting on incompleteness by design. So what is a complete design? Actually, it is a design in which all the problems are pre-specified. There is proper identification of existing alternatives, and we have the choice of most optimum solution. So there are two kind of approaches to a design. First is the scientific approach, and second is the pragmatic approach. So in traditional setting of design, it comes under the scientific approach. So here the meaning of design is in terms of if we consider as a verb or if we consider as a noun, both are different. So if we consider it as a verb, it is mainly the process to the design, and if we consider it as a noun, it is what has emerged out of the process. So in case of contemporary setting, which contains the pragmatic approach to the design, these both meanings are simultaneously used. So in this process, it gives new beginnings to new processes, and it triggers actions. So in scientific design, in practice, it has proper form and function of the system, and it is clearly specified. But and also it has all the self-contained components of the design have proper and clear boundaries. But in case of pragmatic approach to the design, the boundaries of the different components is not very clear, and it is sort of blur. In scientific approach, as the design requires complete representation of problem and identifies the optimum solution, there may be case that in case of instability in design environment, it may fail. So here are the two cases of pragmatic approach design. First is the Linux, and second one is the Wikipedia. So Linux, Linux is a operating system. It was a hobby project of Linus Torvalds. So what he did was he wrote some programs to just see how the 386 processor they worked with the Minix operating system. So after doing this, he just released the very basic version of Linux, that is Linux 001. So that itself tells that the design of that particular operating system is not very complete, and he designed this software as a open source software. So he just released it, and within 2 months he was able to see that 30 people have contributed to the design, the operating system, and close to 200 reports of error and problems in Linux were detected. So what happened after this, the Linux was, the subsequent versions of Linux were released in even and odd versions. So the odd version was like those design, it has some flaws or it has some design errors which need to be corrected by the people who can access the software, since it was open source software, and the even version of the software was the complete, so it did not had any errors in the code. But still at this point there were many possibilities of having some more changes in that. So we can recount that due to the technological engagement and from different contributors, the users and the consumers are the same people. There is nothing like centralized, a single person controlling all the source code and the related things. So, and finally it was enabling the developers to leave their footprint in the source code. So it just involved, it was the involvement from the stake, in this case we can say the consumers and the designers. Second is the case of Wikipedia. So Britannica is a encyclopedia. It is designed to be a complete encyclopedia which involves a large group of experts, and this follows a scientific approach. But in case of Wikipedia, it is again a open source platform where the founder of Wikipedia, he thought that the knowledge of every individual may not be complete, so he just allows them to revise the facts that are present in the articles inside Wikipedia. So in this way we can see that it promotes the generative engagement of the people, and to promote the generative engagement they keep track of all the revisions, and they might report someone who is posting some irrelevant content in the articles. So coming to the discussions related to design participation within pragmatic approach, the distinction between designer and user has blurred. As I said before, in case of scientific approach, the distinction, the boundaries were very clear and stable, but in case of pragmatic approach, the boundary is very blurred, and it results in formation of community of co-designers who inscribe their own context into the emergent design. And tools such as Wiki, GPL is general public license, and the infrastructure provided by internet work with one another to facilitate participation and enable distributed development. In case of pragmatic design approach, it was considered that if there is some interruption, it will not cause the design to failure, but it will promote the change. So the author has described a case where there are two watchmakers. So one out of them is making the watch with all the components, individual components, and if someone interrupts him while the designing of watch, the whole design will, the whole assembly of the components will just break, and he won't be able to design the watch. He has to reinitiate the designing of that watch. But in case of the other watchmaker, the case is that he has a lot of components of the watch, so he has divided it into different subdivisions, and he's assembling the sub parts what he has. So in case of some interruption during the process of assembly, the present part, the sub part which he is assembling will just get disturbed. So he may not be redesigning it from the scratch. So that is the.
So we said, look, there are cost and time overruns. You don't have good information, and therefore, what do, right? And so we said, okay, bring in actors early, make sure you get information, as much information up front as you can. Okay, good thinking. Build in some cost and time buffers. Obviously, it's logical. You don't know, so you need a little bit of contingency. Good thinking. You need a good group of referees to resolve disputes so that costs don't keep escalating. Good thinking. So all of this helps you to control and develop a successful project. We've also talked about flexible designs, right? We talked about how you build Olympic stadiums so that football clubs can use them. We talked about flexibility in the last class as well, right? But the question is, how do we build flexible design? So one of these ideas is coming from this entire community on generative design, right? Where if you look at Wikipedia, right, which is a great example. In the old days, encyclopedias were like the Encyclopedia Britannica, as Aman was just saying. You have a group of editors, you have a group of writers. We decide on what content goes in, right? We put in that content, and then I give you a set of books which you have to buy, and that's it, right? If you buy those books, whatever knowledge is there in those books is the knowledge that is available to you, right? It cannot be automatically modified. It can only be modified, cannot be added to, etc., until you wait for me to bring my next edition in, right, which might be in 6 months, in a year, etc. And even that next edition may not have topics that are of interest to you. So, right, so that's essentially what I call a complete design. I've designed the Encyclopedia Britannica. Here, this is what it is. Take it. If you find it useful, good. If you don't find it useful, don't buy it, right? Compared to Wikipedia, right, where there's no one person who's monitoring the content, right? So you and I can create a stub today, right? I can create a stub, you can add on to it, we can continue to build, more topics can come in, new topics can come in, right? So it is essentially, when you say, okay, is Wikipedia done, right? What do you think? Right? Is Wikipedia done? Doesn't make sense to answer that question. There is no such thing as Wikipedia being done. It's out there, people can continue to add on to it. Just like Linux evolved. It wasn't as if I gave you, in those days on a floppy disk an operating system and said install and this is it, right? You had it was open source, you had the ability for people to continue to add patches, add functionality, etc. And just like with Wikipedia and with Linux, there is some kind of governance structure, right? So there could be incorrect facts that are added to Wikipedia. There could be articles that are probably in poor taste, right, that are added into Wikipedia, and therefore there are ways in which people or bots trawl through these and remove pages and links. And in Wikipedia particularly, you have in bracket citation needed very often, right? So if you read these articles saying, look, somebody has put this in, but it hasn't been corroborated, so you take it. So there is some kind of governance mechanism which we have to decide. Now the question is, so essentially what has Wikipedia done? Nobody developed Wikipedia, people developed a platform on which information is continually being added. So if you say who's responsible for the content in Wikipedia, several thousands of people or several millions of people, I don't know, right? And therefore the content evolves, right? So the younger generation today, based on what they would like, there are new pages that sort of evolve and new ways in which that is written. Even the language with which things are written can change, right? Because different people might write it differently, okay? So this is essentially what we call incomplete evolutionary design. Right? I've designed something that can stand the test of time. Future generations can come in, they can put in all kinds of articles that past generations may not have been interested in. They might write it in a way in which past generations might not have written it, they might interact. So therefore I've created something that is flexible, that as new stakeholders come in, they can continue to use. Okay. Now the question is, can we take these ideas and apply them to infrastructure? Can I build infrastructure projects also with the possibility of users being able to build on and redefine them going future? It's almost the analogy of saying, I'll give you a shell of the house, right, and I'll give you enough sort of grooves on the wall, etc., that you can put in your walls whichever way you want, right, coming in later, because I'm building the house up front, you're using the house later, right? Maybe you're buying the house and renting it out to a third party. How, for instance, do I design this so that each of you can come in and continue to reconfigure the house without having to do massive structural damage, right? And knock off load-bearing walls and columns, which is effectively not possible. If I could do that, then we could continue to keep pace with future generations, right? We could continue to build infrastructure where you will not have a huge redesign cost, or you will not have huge added scope costs because you're needing to do a design in the future. right? So that essentially is the, so the challenge of course is governance, right? How do you sort of, in the Wikipedia example or in the incomplete design example, how do you decide what to go and what could? But the open question, and I don't think in infrastructure we have an answer, right? But the open question is, many projects run into problems because the feature set that is built into the project, you know, there are too many, every new stakeholder comes in and they want a new feature, right, put into the project, and that sort of just becomes very, very costly. And if I don't put in enough features into the project, then 5 years down the line, 10 years down the line, I have a bunch of users who do not find this project useful, right? So is there a way I can sort of create the Wikipedia kind of infrastructure, right, where people can continue to sort of develop, evolve on it, and as a result of which, as a new stakeholder comes in and says, this is what I want, you can sort of say, sure, right, here's a space that's sort of been earmarked that you can reconfigure and use for your purposes. So there is no extra cost that is added onto it. So example, I can't remember who did I have the discussion with in my room yesterday on the parking garage? I think it was Lakshmikant. Oh, Harsh, did you come? Somebody came in and we had this discussion on the parking garage. You know, remember we talked about 3-story parking garage. If demand comes up, build 6 stories. So somebody, I think it was Lakshmikant, who came in and said, another way of looking at flexibility is you build in 6 stories, right? But if the parking demand doesn't pick up, you convert those other stories to some other purpose. What that means, you'll have to, for instance, you want to convert it into residential or into commercial or whatever. You will then have to look at all other kinds of, you know, fire safety, water, wastewater, etc. Right? So you can have configurable options, but how do I, you know, come up with a design that allows for, you know, that is sort of incomplete to start with and allows for new stakeholders to come in and say, okay, now let me put this in, this is what it's going to cost, and you would essentially say, look, we've got most of that worked out in the preliminary design, all you have to do is sort of reconfigure. So I think that's another set of ideas that we'll have to think about with regards to infrastructure, because otherwise there is too many stakeholders to a project and they all often have conflicting you know, demands. And if you start catering to people's demands, then, you know, costs just balloon out of the window. If you don't cater to people's demands, then people could stop the project or stall the progress on the project. So you want a mechanism by which you sort of find this middle ground, and perhaps design for incompleteness or incomplete design offers a philosophical approach. How you would do it on infrastructure, and I'm not 100% clear how I would implement this on an airport, right? But it's something to sort of think about. Okay. So these are all, starting from social network analysis to incomplete design. These are a bunch of ideas that if you think about carefully, you can probably, you know, design projects that can avoid the fate of a Dabol or of a Chad Cameron or of a whatever, right, a Montreal Olympics or whatever you have in mind. Okay, and I think that's essentially what we want to think about, right? So you can in fact itemize what we've talked about over the last 10 or 12 classes and say, here are a set of approaches, right, that we have. Can we use all of them at the same time? Maybe, maybe not, right? But at least for different projects, different approaches might help you design the project in a manner that it is much more useful, right? And we're going to try to then use these case studies coming up to see which of these concepts could be applicable. So the idea is, when you present these cases, right, you tell us all of these cases have run into problems, so we talk about the problem, but then we also start talking about what strategies could we have used, right, that we've talked about in the last 10 sessions or so that would actually be useful with regards to providing better infrastructure. Okay, so I'll stop here for today.